Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 51 of the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got figure S, it's a small arrow, and it's dilated, the origin is the center, so it's going to create figure T, the large arrow. So we just need to figure out how we got from figure S, so I'm going to put a figure S right here, this column right here, how we got from that to figure T. They don't really label that, but you have to kind of read the problem to figure out which one is first, which one is second, figure S to figure T. Well, even if we couldn't see it, they go ahead and tell you that figure S is small and figure T is large, and we're going from small to large. So I'm going to put small to large, and that's important because we can automatically eliminate two of these answer choices just because we know we're going from small to large. Because take a look at these scale factors. So we're multiplying by 2, by 4, by 1/2, and by 1/4. And so here's something that we need to remember about scale factors. So scale factors are what we use to multiply by the x and y coordinates. So when the scale factor is greater than 1 whole, right? If the scale factor is 1, then nothing is changing. xy equals xy, right? But if it's greater than 1, then it becomes larger because you are multiplying by 1.5, multiplying by 10, multiplying by 20, and everything you do is going to become larger. So when my scale factor is less than 1, right, and that's the key pivot point right there, is whether your scale factor is greater than 1 or less than 1, then it is going to shrink. It's going to become smaller because you are multiplying by a fraction, by a half, by a fourth, by a third, by a tenth, and it's going to become smaller. Well, if we're going from figure S to figure T, we're going from small to large, which means we're getting larger, which means I want to look at my scale factors that are greater than 1, which means I can get rid of C, I can get rid of D. Because if I were to take figure S and multiply it by half, it would be half as small. If I were to multiply it by a quarter, it would be really, really tiny. It would be hard to plot. So we're getting bigger. Now let's take a look at either by 2 or by 4. Well, let's just plot some points here. And when in doubt, see if you can get something on the x or y axis, because that makes one of your numbers 0. Super easy. So let's do this figure S. That one right there. So I've got a 0 and a 3 is the y. And that point correlates up there and gets dilated up to a 0, 6. So my two options here are I can multiply by a scale factor of 2 or a scale factor of 4. So what this means is it looks like it's going to be a 2. So 0, 3. So what I'm going to do is I'm going to multiply the 0 times 2. That's my scale factor. Multiply the 3 times 2. And it looks like, yeah, that gets me my 0, 6, which is what I'm wanting. So that looks good. If I were to multiply it by 4, I would put that 4 right there, look, that this would end up becoming a 12. So that's not going to work. So that's looking good. Let me see if I can find one point that's not on the x-axis or the y-axis. Let me see if I can find something just out in one of the quadrants. All right, so I've got that little point right there. So that is 3, -1. So if I do it by 2, right, it should be 3 times 2, and then -1 times 2. That's what these scale factors mean. So that's going to be 6, -2. And does that land? Here's my 6. Here's my -2. Yep, that lands right where it should at the corresponding point on the larger arrow. All right, so that means I am going to multiply by a scale factor of 2. And my answer here is A.